Hey everyone, and welcome back. You ever just look up at the stars and suddenly the whole world feels kind of small?
Yeah, I know that feeling.
Well, get ready to feel it big time because today's deep dive is all about that feeling. We're tackling the universe, and more specifically, just how big it actually is.
It's a question that's been keeping us up at night for centuries.
Literally. But, as with most things, the universe is a little more complicated than just a simple answer.
Understatement of the year. Trust me, we're not just talking big here. We're talking human brain struggles to even comprehend it big.
Exactly. Which is why we're here to break it all down.
Make some sense of the mind-blowing scale of it all. Where should we even start with something like this?
Well, I think there's no better place to begin than right here at home. Good old Earth. Our pale blue dot.
Ah, Carl Sagan. He knew how to turn a phrase.
He really did. But it's true. From out here, it's this tiny little fragile sphere makes you realize just how precious it is.
Absolutely. But to get a sense of the scale we're talking about, let's even just hop over to our nearest celestial neighbor, the moon.
See, already I'm lost. How far even is the moon?
It's about, let me see, 384,000 kilometers away.
384,000. Okay,
Yeah.
yeah, that's a lot of kilometers.
Yeah.
But I'm not driving there anytime soon, so what does that actually look like?
Imagine this. You're cruising your car, windows down, enjoying the ride at a nice 100 kilometers an hour.
Okay, I'm picturing it.
At that speed, it would take you over 160 days of nonstop driving to reach the moon. No rest stops, no coffee breaks, just you, the open road, and, well, space.
Okay, so maybe pack some extra snacks for that road trip.
Definitely. And that's just the moon. We haven't even left our cosmic doorstep yet.
And to think, the moon is what? Like a day trip in the grand scheme of the cosmos, right?
Basically. Now let's kick things up a notch. We're going to visit our very own star, the sun.
All right, sunshine, here we come.
But hold on to your hats because the distance here is so vast that we have to switch from kilometers to a whole new measuring stick, the astronomical unit, or AU.
Ah, yes, the AU. It's like the space version of miles instead of inches.
Exactly. 1 AU is the average distance from Earth to the sun,
Which is?
roughly 150 million kilometers.
See, this is what I'm talking about. These numbers are already getting out of control.
And it's not just the distance, it's also the time it takes to travel it. Even light, the fastest thing in the universe, traveling at a mind-blowing 300,000 kilometers per second.
Okay, seriously, per second, light is fast.
It is. But even traveling at that speed, it takes more than 8 minutes for sunlight to reach us here on Earth.
So the sunlight we're seeing right now is actually 8 minutes old.
Exactly.
Whoa, it's like a cosmic time delay.
It really makes you appreciate just how vast these distances are.
Okay, so we've covered the moon, the sun.
Eh.
What about Mars? Isn't that our next door neighbor in space?
You could say that. Mars is a bit of a moving target, though, literally.
How do you mean?
Well, the distance between Earth and Mars varies greatly depending on where they are in their orbits around the sun. Sometimes it's closer, sometimes it's farther.
So how far are we talking?
At its closest, Mars is about 54.6 million kilometers away, which, believe it or not, it's actually pretty close, relatively speaking, of course. But when Earth and Mars are on opposite sides of the sun,
Oh, that can't be good.
that distance stretches out to a whopping 401 million kilometers.
Okay, yeah, that's a bit more than a hop, skip, and a jump.
It is, and it's one of the big challenges of planning missions to Mars. We have to time it just right to make sure we can actually reach it.
So it's not as simple as booking a flight online. More like trying to hit a moving target with a very, very slow arrow.
Pretty much. But hey, we've landed rovers on Mars, so clearly it's not impossible.
True. Okay, but we're still in our own solar system here. There's got to be more, right?
Oh, there's way more, and this is where things get really interesting.
Hit me with it.
Buckle up, because we're about to enter the realm of light years.
Light years.
Right.
Okay, now we're talking serious cosmic distances.
We are. Get ready, because once you go light years, you never go back.
Well, I'm definitely not going back. This is way too interesting. So light years, remind me what those are again.
A light year is the distance light travels in 1 year.
Right. Light travels
Mm.
at the speed of light.
Yeah.
For a year.
Yeah.
So, like, how many kilometers is that?
About 9.5 trillion kilometers.
Yeah, okay, that's
About.
a whole lot of kilometers.
Okay.
I get why we switched to light years now.
It's hard to even fathom, isn't it?
It really is. But, okay, so light takes a year to travel that far. Does that mean if we ever want to visit other star systems, it'll take us, like, literal years to get there?
Well, assuming we could even travel at the speed of light, which is a whole other conversation.
Yeah.
Yes, Even then, it would take us years, if not centuries, to reach even our closest stellar neighbors.
Centuries. Yikes. Okay, maybe interstellar vacations are off the table for now.
Probably a good idea to solve that whole faster-than-light travel thing first.
Agreed. But you mentioned stellar neighbors, so who's our closest one?
That would be the Alpha Centauri system, specifically a star called Proxima Centauri. It's our next-door neighbor, galactically speaking.
Oh, yeah, I've heard of that one. How far is it?
A mere 4.4 light years away.
Mere. Okay, so even if we figured out that whole faster-than-light travel thing, it would still take us at least 4 years to get there.
At least, assuming we could somehow travel at the speed of light, which, just to reiterate, is not currently possible.
Yeah, I hear you. Still impossible with our current tech. Got it. But 4.4 light years, isn't that like a stone's throw in space terms?
You'd think so, wouldn't you? But let's put it into perspective. Remember Voyager 1, that little probe we launched back in the 70s?
Oh yeah, Voyager 1. The one that's been cruising through space longer than I've been alive. It's still going, right?
It is, and it's traveling at a pretty impressive clip, too. About 60,000 kilometers per hour.
Okay, that's pretty fast.
It is. But even at that speed, it would take Voyager 1 an estimated 70,000 years to reach Proxima Centauri.
70,000 years.
Mm.
So our closest neighbor is still ridiculously far away.
It is, and that's just our next-door neighbor. We haven't even talked about the Milky Way yet.
The Milky Way, you mean like our entire galaxy?
The one and only. And it's just one of billions and billions of galaxies scattered throughout the universe.
Billions of galaxies. See, this is what I'm talking about. These numbers. How am I supposed to wrap my head around billions of galaxies?
It's a lot to take in, that's for sure. But for now, let's stick with our own galaxy, the Milky Way. And consider this. All of human history, everything we've ever done, is contained within a tiny bubble of radio waves, extending just about 100 light years out from Earth.
Wait, really? You mean all our radio and TV signals, everything we've ever beamed out into space, it only reaches 100 light years. That's not very far.
It's like shouting into a vast cosmic canyon. Our radio waves haven't even had time to travel to the other side.
So basically to the rest of the galaxy, to anyone out there listening, we're basically invisible.
More or less, at least for now. But okay, let's zoom back out a little. Because our Milky Way, as mind-blowingly enormous as it is, it's also part of an even larger structure.
There's something even bigger than a galaxy. Come on, now you're just messing with me.
I wouldn't dream of it. No, it's true. We're talking about something called the local group.
The local group? What is that? Some kind of galactic club I haven't been invited to?
Something like that. It's a collection of over 50 galaxies, all bound together by gravity. Think of it like a neighborhood of galaxies, with the Milky Way being just one house on the block.
Okay, so how big is this neighborhood?
The local group spans about 10 million light years.
10 million. So even our concept of neighborhoods is way off when it comes to the universe.
Just a tad. But it gets even bigger than that.
Bigger than 10 million light years. How is that even possible?
Remember when I said the Milky Way was part of a larger structure? Well, the local group. Even that's just a small part of something even more mind-boggling.
Okay, I'm officially lost. What are we talking about now?
Superclusters. And ours is called the Virgo supercluster.
The Virgo supercluster.
Yep. And the local group, just a tiny little part of it.
Okay, I need to go lie down after this. Superclusters. So, like, if the local group is a neighborhood, a supercluster is.
A supercluster is more like a whole city of galaxies.
A city.
Yeah.
Yeah.
Think of it like this. Each galaxy is a building, right? And all those buildings are grouped into neighborhoods, which are like those local groups we were talking about.
Okay. I kind of see where you're going with this.
So all those neighborhoods together, they make up a city. That's our Virgo supercluster.
And of course, it wouldn't be a deep dive without some ridiculously huge number to go along with it, right? How big are we talking?
The Virgo supercluster is about 110 million light years across.
110 million. I'm starting to run out of words to describe how big these things are. Like every time I think we've reached the limit, it turns out there's another layer, another level. So are we at the top yet? Or is there something even bigger than a supercluster?
You know, for a while, we thought superclusters were the biggest structures in the universe, but then...
That's never good. What happened then?
We discovered Laniakea.
Laniakea, what is that?
It's Hawaiian. It means immense heaven, or sometimes open skies, which is pretty fitting, considering...
Considering it's even bigger than a supercluster.
You got it. We're talking about a structure so vast it makes superclusters look tiny.
Okay, now you have to tell me. How big are we talking, really?
Laniakea spans over 500 million light years.
500 million. Okay, yeah, immense heaven is right.
Mm.
But what exactly is it? Is it just a bunch of superclusters hanging out together?
It's more like, imagine a cosmic web, right? With filaments of galaxies all interconnected, stretching across unimaginable distances.
Okay, I'm picturing it, sort of.
Laniakea is like one of those filaments.
Mm.
A single structure containing hundreds of thousands of galaxies, all moving together in this intricate cosmic dance.
Hundreds of thousands.
Yeah.
And they're all moving together. Where are they even going?
That's the big question, isn't it? We're still trying to figure that out. But here's the thing. All the galaxies in Laniakea, including our own Milky Way, were all flowing towards a mysterious region called the Great Attractor.
A great attractor. Okay, now that sounds ominous.
It does, doesn't
Yeah.
it? It's like this massive gravitational anomaly pulling on everything around it.
So what is it? A black hole? A giant cosmic vacuum cleaner?
We're not entirely sure yet. It lies behind what we call the zone of avoidance, which is an area of space where our view is obscured by dust and gas in our own galaxy.
So we can't even see it.
Not directly, but we can see its effects. It's like
Yeah.
an invisible hand pulling on the fabric of space-time, drawing everything towards it.
Okay, so
Mhm.
what happens when we get there?
Again, that's something we're still trying to figure out. It's not like a sudden crash or anything, more like a slow gravitational waltz that will play out over billions of years.
Billions of years. Okay, so maybe I don't need to worry about it too much right now. But this great attractor, that's not even the edge of the universe, is it?
You're right, it's not. It's just the furthest we can currently observe. We call it the observable universe.
Observable, meaning there's more beyond that.
Potentially, yes. The observable universe has a radius of about 46.5 billion light years.
46.5 billion
Yeah.
light years.
That means light from beyond that distance simply hasn't had enough time to reach us yet. And don't forget, the universe is constantly expanding, too.
And that expansion is accelerating, right?
Exactly. So there might be parts of the universe we'll never be able to see, no matter how advanced our telescopes become. It's like having this cosmic horizon that we can't peer beyond.
I have to admit, that's kind of a humbling thought, knowing there's so much out there
Yeah.
that we may never even see.
It is humbling, isn't it? But it's also incredibly exciting.
Yeah, I guess it's all about perspective.
Exactly.
Well, I don't know about you, but I think my brain is officially full.
Mine.
We've covered a lot of ground today, from our own little planet to the edge of the observable universe. And even though it seems like we've barely scratched the surface.
We've only just begun to explore these cosmic mysteries.
Exactly. So, to everyone listening, I have a challenge for you. Next time you're looking up at the night sky, don't just see those stars. Remember what we talked about today. Think about the vast distances, the countless galaxies, the mysteries that are still out there waiting to be discovered. And hey, maybe someday we'll have even more mind-blowing insights to share with you in a future deep dive. Until then, keep looking up.